Electro-Stone Lab business plan for the development of Fulgurite stone synthesis technology. Summary. According to preliminary calculations, this technology has many areas of application. But to start its development, you can use its simplest application, the construction sector. Samples of porous stone, which is stronger than conventional foam concrete, were obtained in a laboratory format. Such a stone does not require the use of cement. It is enough to take ordinary quartz sand and a few available and inexpensive chemical components. This mixture is placed in a reactor and, under the influence of electricity, is fused into a porous stone, similar to the natural mineral, fulgurite, obtained from a lightning strike. Moreover, ordinary earth can be used to fuse it into such a stone. Both options differ in color and strength. So the raw materials for production are practically underfoot and do not require the creation of a cement production plant. This is a serious advantage, and according to preliminary estimates, the cost of such material will be lower than the cost of porous cement blocks. Therefore, construction companies will be interested in possessing such technologies. In order to get maximum profit in this area, you need to organize a package of services like this. A construction company buys a package of services for $1 million, and initially it includes the supply of a small machine capable of producing a small number of blocks. The buyer independently tests the machine using several recipes for obtaining blocks. The buyer decides to launch mass production and, under the guidance of the technology seller, begins the construction of a large machine where he needs it. At this stage, the buyer and seller decide the production volumes of this installation and determine the amount of payment to the seller, for example, $10–100 million, during the construction of the machine. The buyer undertakes to transfer the amount under the contract to the seller of the technology, after launch. The seller of the technology undertakes to monitor the buyer's production for life and periodically transmit information with new developments of recipes for new materials. Under this scheme, the technology seller continues to work in his laboratory and maintains contacts with all buyers. The nature of the payments can be organized differently, but the basic idea is that the buyer pays more for the information. Laboratory. The laboratory building can have an area of 1,000 square meters and be located within access to an electrical network with a power of 100 to 1,000 kilowatts. It should consist of a reactor room, an exhaust gas filtration room, a process control room, a warehouse, a staff rest room and an office. In the reactor zone, after smelting the stone, 1 to 2 people work using various mechanisms. They open the reactor, remove the stone, wash it and move it. They also monitor the condition of the filters for the air sucked out of the reactor area, and they also maintain these filters. I am in the process control room and turn on the reactor and all the other equipment. The monitor of video surveillance cameras of all rooms is located here. In the future, another person will work here. All people in the laboratory must sign a non-disclosure document. You may need a full-time manager and someone else. People involved in registration and sale of technology, a lawyer and someone else can work outside the state. Initially, considering Singapore, I will need an assistant for relocation and communication. Ideally, he will also manage the construction of the laboratory or the use of existing infrastructure. We start working with him remotely. He helps me move to Singapore and hires the right people to build or use existing infrastructure. I design the laboratory and, with the help of an assistant, communicate with electricians and so on. The launch process must take place no later than 1 year. After which, In a few months, a machine will be developed for sale to construction companies according to the principles specified in the resume. At this time, people begin to work actively, drawing up all the papers and contracts with various construction companies. With the help of hired employees, I assemble these machines in a warehouse. Machines are delivered to customers and work is carried out on the services described in the summary. Thus, the project is expected to pay off in the second year of the laboratory's operation. With optimistic forecasts. With pessimistic forecasts, this period can increase significantly. This can be caused by bureaucratic delays, illnesses, natural disasters, low purchasing demand, and low interest in new materials. Prospects for the laboratory. As soon as the laboratory pays off the investment and becomes self-sufficient, it will be possible to move on to other areas of application of the technology. To do this, it will be necessary to increase the area and create an experimental reactor zone with a separate filter system. The number of employees will also need to be increased. In this part of the laboratory you can start with the disposal of liquid chemicals and nuclear waste. It will be necessary to take into account toxicity factors and prevent emissions of waste gases. Identify problems in chemical production and the cost of solving them. And then begin experiments on fusing liquid waste with sand, so that in the end they will bind into a solid state and there will be no risk of environmental pollution if they spill in storage. Probably, large chemical enterprises that have problems with recycling can pay well for such a recycling technology. Even more financially promising could be the disposal of liquid radioactive waste. Similarly, fusing it with sand. This work will need to be carried out very carefully using various analytical equipment and conducting a lot of chemical analyses in third-party analytical laboratories. There is a risk of not obtaining clean technology. There may be gas emissions that are difficult to detect. Another direction is associated with low-energy nuclear reactions, where there are no dangerous emissions and radiation. Based on a lot of experimental data from various researchers, including mine, one can expect that nuclear transformations occur during the synthesis of this stone, even with the use of ordinary sand and simple chemistry. Therefore, in this direction it will be necessary to carry out many chemical analyses of the raw materials and the resulting stone. It is likely that one of the reactions will give beneficial results. Inexpensive initial atoms will partially transform into expensive ones. Thus, by processing inexpensive raw materials in a reactor, it is possible to obtain an analog of ore of valuable elements. If a favorable reaction is eventually found, then it will be possible to arrange our own production of this valuable ore, which can be sold to processing companies. Another direction is related to the synthesis of heat-resistant materials for special applications. As a basis, you can take corundum material, samples of which I have already obtained, and develop the synthesis of structural blocks from such material. They can be used in industry, wherever there are high temperatures. And the final option for today is the synthesis of new materials. This will require an analysis of the market and scientific developments, a search for those areas that are required today and attempts to synthesize such materials. For example, I received samples of magnetic materials that can be used for radio absorption and shielding of certain devices and equipment. Risks. As the reactor power increases, reactions may proceed differently and forecasts may be erroneous, both for the worse and for the better. Experience. Samples received. Porous quartz is synthesized from ordinary quartz sand and is a porous stone substance that can be used as foam concrete, but its production does not require cement, but requires electricity and inexpensive chemical components. It is environmentally friendly. Various modifications can be more durable than foam concrete. Porous ruby corundum. Similar to foam quartz, but the hardness corresponds to ruby corundum, i.e. it is more durable, can also be used for design with UV backlight, because the ruby underneath glows. More heat-resistant than foam quartz. Porous obsidian is similar to foam quartz, but due to the addition of iron it has a black color. This is the cheapest additive. But you can add other metals and get different colors. It can also be used for decorative purposes. Porous ferrite can be used in radio absorption technology. Porous glass can be synthesized from ground glass waste, used in construction. Properties weaker than quartz. Various experimental porous alloys based on sand, clay, soil, corundum, etc. Scope of application in development, but also the above areas. Porous alloys based on sand with liquid or powder radioactive waste can be used to bind liquid waste into a solid state. To eliminate the danger of leaks, the energy costs for such binding are lower than when pouring molten glass. The issue of the release of gases from the reactor during synthesis has not been studied, but can be eliminated through the creation of an advanced exhaust system and condensation of emissions, followed by return to the reactor for fusion, binding of various liquid and powdered chemical wastes into a porous stone, with the aim of fixing them in a solid state. The processing of toxic into non-toxic substances can probably be considered. Creation of a stone coating on metal with sharp spikes for drilling rigs. Quarried corundum version. Some samples have been tested in contact with high-temperature sources. They can be used in high-temperature installations as a structural material. The ability to directly fuse earth into porous stone on site opens up broad prospects for the construction industry. Fused organic material with sand, etc. can still be considered for decorative purposes. Unstudied samples can possibly be obtained. Diamond porous structural material can have the highest hardness. Carbon porous material can have high temperature, strength, radio-absorbing properties. Porous pyrite can be used for decorative purposes with imitation gold. Porous high-temperature minerals can be obtained from appropriate components for structural and other purposes. New materials with useful properties. Low-energy nuclear reactions can most likely take place in this reactor, which can be considered as an option for producing expensive elements from cheap ones. There may likely be other applications that are currently difficult to predict.